My name is Eric Johnson. I'm a technical program manager. I work on Google's Compute Engine team up in Seattle. And I thought I'd take 25 minutes of your time today to talk a little bit about Google Compute Engine and open source technologies. Over this last year, as you saw previous session and probably heard earlier in the keynote this morning, Compute Engine last year in 2013, we went all the way from invite only, and then in I/O we went to open signups, and then in December we went to general availability. So during that last year also, I and several of my colleagues worked on contributing code and documentation to some popular open source packages out there, so that if you're already using those technologies, you'd be able to go ahead and use those with Compute Engine as well. But before I get into the specifics of what we've done there and some of the projects we've contributed to, I wanted to talk just a little bit in general about how Google uses open source and how we're effectively built on top of open source. It would be incredibly challenging for Google to exist as you know it today without the foundations of open source technology and open standards. We'd serve hundreds of millions of users across Gmail and YouTube and Maps. And none of that would be possible without the ability to be able to get in, kind of roll up our sleeves and take a look at the source code of some of the technologies that we use, make modifications to that stuff, and try and squeeze out every ounce of performance and scalability that we can. So, there's other alternatives, obviously, right, besides open source. There's other closed source, binary distributions or binary packages out there that you can use. And so I guess as I think about sort of maybe the differences between the two, a good analogy to me is painting, right? So if you're a painter and you start off with a blank canvas, you have a couple of options, right? You can choose what your subject is going to be. If you want to do a portrait or a landscape, you can choose between different styles like abstract or expressionism, impressionist. And kind of sort of the sky's the limit, right? And as you go through, maybe and you're working on your masterpiece, I think one of the things that's great about open source software, which fits in well with this analogy, is the ability to be able to sort of make your own modifications to it. So I kind of, as I was going through looking for pictures, this one kind of struck out at me. And I was thinking, as Rembrandt's sitting here painting this, he's looking at this and he's like, you know what, I've just finished this great big masterpiece. And with the exception that I think it's a little bit too formal. He originally had a hat on everybody. And he thought, all right, well, it's the 1600s. I'm going to make it a little bit more casual, kind of laid back. So he just painted over the hat on one of the drapers pictured here. So that's an example of being able to take and start off with whatever you want and be able to make modifications to it. If I were to contrast that with sort of the closed source world and binary packages, you can still create a painting, right? But maybe your options are a little bit more limited. So you don't. Maybe the paint by numbers is a good way to think about that, right? You are given a set of software to build out your technology, but you don't have as much flexibility. The design is already chosen for you. The color palette may also be chosen for you. Even the arrangement of those colors might be chosen for you. And you don't have the ability to be able to go in and make modifications to it. So, at the end of the day, you can still finish up and you'll have a decent painting. But you just don't have the flexibility to kind of make it your own. So how does Google use open source software? So first and foremost, we use Linux. There's tens of thousands of Googlers employed all around the world. And every one of those Googlers runs, well, a very large number of them, let's say, run either Linux or a Unix derivative, right? Unix had its sort of roots in open source. And all of us pretty much use that. There's utilities installed on our laptops and our workstations that are all open source, like sed and awk. These are utilities that engineers use every day, all open source, right? It enables us to do our jobs. But not only do we run Linux on our laptops and workstations, but we also run it in our data centers. So every service that you use at Google is powered underneath that by Linux. Another way that we use open source is our development environment. We use popular open source programming languages like Python or Go. a lot of the things that we do to get our job done on a day-to-day basis, right? We're working on source code, we're making modifications to that. We use open source integrated development environments, IDEs. We use open source text editors for modifying source code. We use open source version control to record changes that we make to the system and have that sort of history of changes that we've made. Compilers that we use to compile the software, all of that is open source as well. But open source has a lot of its roots, and the ability to be able to develop open source software is based on open standards, right? So these are standard organizations that have gotten together and defined in the open how a certain thing should work, the characteristics of it. And then a lot of times they'll create reference implementations based on those standards. So if you think about the presentation that you're watching today, whether you're here locally or you're watching it remote over YouTube, there are a lot of standards that are involved. The original content of this is done in Google Apps, in Slides software. All of that data actually lives someplace in a Google data center, right? And it's being served out over the network. The network is defined by open standards. You have protocols like TCP, IP, and DNS, and HTTP in play. All of that has been defined as open standards. Even the content on the slides, the images that you see, the content of the slides itself, that's being displayed via HTML, CSS, JavaScript. Again, all things developed off of open standards. Even the text on the screen, right, are character encodings for Unicode or ASCII. Again, open standards. Even just displaying this stuff uses HDMI, DVI, VGA, or something like that. Also, video encoding over the internet, right? H.264. Again, all open standards. So Google clearly benefits from open source software. Like I said before, everything that we've done is built on top of open source software, and we really wouldn't exist in the way that you know us today without that foundation in open source and open standards. So clearly we're benefiting a lot, but does that benefit you at all? Well, you know, one of the key foundations of open source is collaborating with others and sharing those modifications back and forth. And Google does participate in that as well. So last year, Linux Foundation, well, every year they publish a report called Who Writes Linux. Last year in 2013, Google moved up into the top 10 contributors, corporate contributors to the Linux kernel. And you might think, okay, yeah, Linux kernel, Android runs Linux kernel, it's probably all Android development, right? Well, in an article published by Ars Technica, they interviewed Greg Kroah-Hartman, who is the Linux stable maintainer, Linux kernel stable maintainer. You know, and Greg was quick to point out that Google is really doing work all over the kernel. In fact, you heard, if you saw Joe, the previous session, Joe Bita mentioned that we contributed C groups. I think that was back in like 2007 and 2008, and that's sort of the underlying technology behind containers and some of the technology that you see out there in the open source world like Docker today. So not only are we contributing to, actively contributing to the development of the Linux kernel, Google also, through stipends and mentorship, has a Google Summer of Code project. And what that is we do pay stipends to students to contribute to open source projects. Google Summer of Code, I think, was started around 2005. And since that time, through that program, we've contributed over 50 million lines of code to over 400 open source projects. So those are examples, those are great examples of Google contributing back to existing projects. Some of you are probably already also aware that Google does initiate a lot of open source projects. So to name a few, obviously Android, everybody I'm sure has heard of that. Chromium is a foundation behind both Chrome web browser as well as Chrome OS. The Go programming language, the V8 JavaScript engine, which really is the thing that makes Node.js sort of under the hood, makes Node.js possible. So all of these are developed, you know, were initiated by Google, open sourced from the beginning. They all have very active contributions, not only from Googlers, but also from other external corporations and even external developers that are interested in the technology and want to participate in it. So let's talk a little bit about Compute Engine also. So lots of announcements today with Compute Engine. And as we mentioned, because it's a Google service, it runs on top of open source software. So some of the open source software that we use to power Compute Engine, obviously it runs on top of Linux servers in our data centers. And we use KVM as our virtualization layer. We provide a public API, and that's defined by open standards, right? It's an HTTP REST API. So there's nothing sort of unique about that. There's nothing proprietary. It's completely open based off of standards. Even the images that you can launch, the virtual machines that you can spin up, the operating systems that we supply by default are Debian, CentOS, Red Hat, you saw, RHEL, and SUSE. FreeBSD, you can even spin up your own images as you probably heard in the previous presentation. So again, open source technology through and through. So now we're kind of ready to get into some of the work that we've done for open source projects that are out there that do support Compute Engine. And kind of the best way I think to probably start this off is just sort of let's use the hello world of Compute Engine. So what I have up here is 13 lines of Python code. And what this will do is create a single virtual machine in Compute Engine. And this uses the open source Python library. It's an Apache Software Foundation project called libcloud. And it's a multi-cloud library written in Python. So you can use this with other cloud providers as well. So recognizing that there might be users out there that would be using another provider that maybe would also want to try Compute Engine, we went through and we contributed code and documentation, sample scripts on how you, if you're already using libcloud or an application maybe that's even built on top of libcloud, can go in and basically make some minor configuration changes for authentication. And by and large, it should probably just work. You know, you may have to make some customizations there in terms of the machine size or the location. But otherwise, it's same concepts that you would get using libcloud with any other provider. But maybe Python's not your thing, right? So maybe you're a Ruby developer. Well, fortunately, there's another library out there that's very similar to libcloud in that it works with multiple providers. And here I've got a snippet of Ruby code, which does effectively the same thing. In fact, the code almost looks identical. This FOG is a open source library, all in Ruby. And again, you can use that with multiple cloud providers as well. And this is another example of where Google contributed code back over to the FOG open source community to make sure that any FOG developers or applications that are built using FOG can now also use Compute Engine. So, but there's this other language out there called Java that's very popular. And there happens to be another open source project very similar to both libcloud and FOG that allows you to work with multiple cloud providers. And so here I've got 12 lines of code. This one's a little bit different in the sense that this code snippet here uses, and this is a JCloud's sort of idiom, that they have templates that you define where you set the node attributes or the instance attributes that you want to create. And so here I'm just assuming that I'm using the default and that those are sane values. It's probably a single core machine type, and hopefully it's, you know, in a region that's going to be close by. But these are all attributes that I could modify and change, and then I can specify my exact environment that I want with JClouds. So again, as I had mentioned, Google had contributed to code. With the exception, I think, of JClouds, we've kind of poked at it a little bit and offered some help here and there, but by and large, this was done by the community itself. So I just showed you that you can use programmatically, right? You can create your own virtual machines and spin those up. And that's great, but now you want to put them to work, right? So the next thing that you would do once you have your instance up and running is you probably want to go ahead and put your own software on it or run a service on it. And the way that you would normally do that, I guess just sort of out of the box, is you'd probably SSH into that. And since they're all open source Linux distributions, you'd use your package manager to pull down your packages, deploy your application, and get it configured. And I think also you saw in the previous talk, if you saw that one, we talked a little bit about snowflakes, right? So you're going to spend a lot of time tuning and tweaking this, right, and getting it just right. But then the next time that you want to go and do that, you have to kind of remember, like, oh, what were all those packages I had to go, or how did I get around that one particular dependency? Oh, yeah, that's right, I had to compile that thing from source. So there's a lot of things, right, that you want to make and turn into sort of a repeatable process. There are a lot of open source configuration management tools out there that you can use. And all of these now, through code contributions by Google, support Compute Engine. So the two biggest ones that you probably have heard of, Puppet and Chef. But then there's also newer ones that are coming up, SaltStack and Ansible. And again, all of these support Compute Engine. So tying back into the previous conversation about the getting away from snowflakes, right? All of these tools allow you to create a configuration that represents the desired state of your server or servers, your virtual machines in the cloud. It's like a declarative syntax. It just says, it doesn't tell really how a machine should get itself configured. You just say, here are the services I want, the packages I want, the users that are created, file permissions, anything that you can think of that you would normally do through just manual one-off commands, you can capture in a configuration file. Those configuration files can be versioned, so you can track changes to that stuff. If you make a mistake, you can roll it back. They're all strive to be idempotent, so you can rerun the same command over and over again and tune and tweak it and run the same command, and it'll only install things that have changed. Or it's a great way to try and like tune and get your environment set up just the way you'd like. And as I mentioned, Google contributed a lot to the development of Compute Engine support into these. There's a lot of other open source packages out there, and here's some of the other popular ones that we've come across. In some cases, Google has contributed either directly to the project or through code or just through documentation. Like Docker, I think, for instance, one of our developer advocates put together a nice clean set of instructions. It's like 10 lines of code to get up and running with that. CoreOS has an image that you can put into your project, and you can run the CoreOS image right inside of Compute Engine. Vagrant is another tool that you can use to kind of quickly spin up a development environment, and that works with Compute Engine. And Packer is another project that allows you to sort of bundle up your image and get it customized the way you want, and then reuse that. So let's flip over to a demo. So we should have a terminal come up here in a second. And let me just cat out this file. So this is very similar to the little hello world example, right, in Python that I showed you before. The only couple of differences here to call out, obviously lines 5, 6, and 7 have my authentication credentials in it for my project. But the only, one of the other differences here is on line 11, I'm going to use a wrapping function that we added to libcloud, which allows you to create multiple virtual machines with a single method call. So rather than having to re-execute the single create node inside of a while loop, we sort of do all of that for you. And let's see what else. Oh, so I've got it hard-coded in there on line 14 that we want to create 100 virtual machines. And then on line 16, what we'll do is we'll print out, that'll return an array of created virtual machines. And then so on line 16, I'm going to print out sort of the length of that list, and hopefully that comes out to be 100. And then how long did that take? So let's just go ahead and run this. So let's call this, hello world times 100, I guess. So I'll flip over to the developer console here, and you can see this is the demo virtual machine that I was on when I executed that command just now. So we should start to see a couple instances spin up. Okay, so flipping over to the disks tab, our virtual machines now use persistent disks. That's your only option right now. There is no ephemeral disk or scratch disk. So what this has done is it's created the 100 persistent disks. Each is 10 gigs in size, and each has the Debian image loaded on them. And then we also have the 100 instances that are being created. And so each of those instances, it's matched. I should have pointed this out in the sample code, but I give it a name prefix of LC for libcloud, and then it just depends on an auto-incrementing integer for each instance it creates. And then that also matches the name of the persistent disk, and so then that's what it uses as its boot disk. One thing I'd like to point out, as you're getting up to speed with Compute Engine, and you want to learn our API, there's a couple things. So what I did here is I drilled down into just one of these instances, in this case LC001, and I'm scrolling down and I'm looking at some of the attributes on it. But down here at the bottom, we have a couple hyperlinks that you can click on, and this will show you the exact REST API that defines this instance. And so that's a great way to learn the API. And then there's also, Compute Engine provides a command line utility called gcutil, which is part of gcloud. And this gives you the exact SSH command that you can just cut and paste to SSH directly into that machine. So I wanted to call that out because that's a great way to get up and running with Compute Engine. You know, just kind of quickly drilling through some of this stuff, snapshots. You can, from a persistent disk, you can create a snapshot off of that. And snapshots are stored globally. So this is a great way for you to replicate data around. You can create your instance, customize it the way you want, and then take a snapshot of that persistent disk, and then bring up another persistent disk, let's say in Europe, and an instance based off of that, and you've just replicated your instance over there. So let's go back to the instance list. And if we scroll all the way down, hopefully we'll see down to 99. So let's find out how long did it take us to create a 100 virtual machines. So 100 in 1 minute and 27 seconds. And these, again, they're all Debian images. You can SSH into any one of these, and we had 100% success in less than 2 minutes. So if we can flip back to the slides, please. So what's next? So there's a lot of things that came out today, right? So as we've been working to contribute code back to the open source community for supporting Compute Engine, we're always iterating on things. We're always changing things. And it's a difficult job to kind of keep up with that. And it's a small group of us within Google that are kind of contributing some of our part-time work to this stuff. And in the spirit of open source, we'd love to collaborate with you. You can find me on GitHub, ERJonso. And if you have a project that is an open source project out there and you'd like us to see maybe kind of help you out either with some guidance or even some code or documentation, feel free to do an @mention on your project and kind of bring it to my attention. And if it's not something that I can personally take on, there's a lot of people that work at Google, and I might be able to find somebody that can help you. I'd also like to point out we have a GitHub organization called Google Cloud Platform, and there are a lot of great repositories set up there that are samples, applications, demos, that type of thing, across all of the Google Cloud Platform services. So I really encourage you to check that stuff out. And I'd like to thank you for your time.